watch it later.
Well, hello, Diane. You can start. I started recording.
Yes, let's go. Yeah, today we'll explore two new simulators. New type of simulators is a heat exchanger and the Reboiler. And the Reboiler. This equipment connected with heat transfer without any mass transfer, only energy. I think all of you already used RTsim career and done the first assignment connected with the simplest simulators as buffer tank and reflux tank. And at this stage, you should clearly understand how to work in RTsim career. And if you have a question, don't forget to ask our team or ask help your colleagues in WhatsApp chat. So yeah, use it and don't forget done assignments. Do activities in the social medias, in particular in LinkedIn. We see all, and our team always send some reactions, comments, and likes to your posts. Let's open heat exchanger in the training mode. Heat exchanger in a technological process management mode. Yeah, here you see two loops. One is a heating agent, second is a cooling agent. We will call it coolant. And these signs let us know the direction of our flows. To start manipulation, we should start calculation. And diagrams help us understand all process. Let me remind that field workstation is like a simulation of all operations on real unit. And DCS console room is a operator's screen. And here you see that all parameters in the normal technological conditions, but here we see new type of device. It's the first name is Q. Q means quantity, and it means quantity of vapor phase and a liquid phase in our flow. Yeah, and let's check. Operation action log is empty because we didn't anything do. Other process parameter log, here all devices, current values, and set points. And at this window, it's easy to understand is all parameters in normal conditions or not, because we can compare current values and lower alarm values, high lock level, and lower lock level. And let me remind that A means general, and B means backup. Other important log is this status of the shutoff and control valves. Here, current valves, statuses, and modes. Because when you see big models, in particular latency prevention unit or primary distillation unit, it's better to use logs and compare it. And if you have 2 or more screens, you can expand this flow sheet. Yeah, and let's back to our devices. Let's open the trend of first device. At this trend, we see that the current value is 0.7 is the coefficient of vapor phase in all phase, including liquid phase and vapor phase. 1 means that all product, all flow is in vapor phase. 0 means that's all phase in a liquid phase. 1 means vapor phase. Yeah, and temperature device at heating agent. You see here tier 6 control the shuttle valve and the coolant, because our main goal in this case, it is support temperature at outline of our is 130 Celsius degree, and after cooling, it is in the temperature is 110 Celsius degree. So we can say that our heat exchanger cool our product in to product line or something else, or to storage, because sometimes heat exchangers should heat our flows, and I will show you Reboiler. The main idea of Reboiler, it's support the temperature in rectification column. Yeah, and let me remind that if you have question, you can drop your questions to Google Chat. Yeah, Guys, could you please let me know are you seeing my screen or not? Because yeah. So dear participants who can't see, please review the session or rejoin to our webinar. Yes, so let's understand how to regulate the temperature and the dependence of different flows in this heat exchanging system. Let's open the front of our device. Yeah, that's good. You can see the transfer of our heating agent product line. And the product trend. Yeah, and let's go to distributed control system. And now we should operate this unit like operator of heat exchanger system. So we should reach some parameters and done a task. Let's imagine that we should evaporate the product as much as we can. Now the call in at this temperature device, 110 Celsius degree. Let's set here new parameter, in particular 100. And we see that our temperature device will already opening the shutter valve of our coolant and regulate all loop, because there's only one shutter valve at this line. Because this manual valve already open, this already open, and this shutter valve we can control from distributed control system remotely. Yeah, and about feedstock, and this quantity device indicate that the product is stable and the vapor phase is about 70% of this flow. But we increased amount of coolant agent, and we need decrease the temperature. You see that our simulators is dynamic, and the current value not equal 100 Celsius degree. It's changed because all processes with moving of flow is inherent. And we see that the amount of quantity of this the vapor phase is about 27% in outline of a product line. But our goal is make liquid as much as we can. To do it, the better way is manipulate directly this shutter valve, not control temperature device. So, yeah, and you see that now process is stable and it can increase a little bit. But to control our coolant and make all product in a liquid phase for condense the product as much as we want. To do this, click on clicking on this control valve. Not our goal. We should click on temperature device and switch it to manual mode. Click on out. Click on manual mode. Yeah. And now our valve of our coolant, it is in manual mode. So we can control directly the opening degree of our valve in MIVI window. Click on MIVI. And now our valve now our valve and whole coolant line fully open. And so we see that we have restarted the condensation of our product, and the product temperature decreased and decreased. Yeah, that's good, because storage of our polymer or storage of our liquid product is easier than storage of gas. Yeah, I have a question. Please, sir, can you see technological process management to do a shutdown. Rashid, I will show you today shutdowning of our unit and all of our models, simulators has shutdowning scenarios. What green, red, and yellow, orange colors do they represent? Do you mean I think you mean the color of pipelines. We have rules. Heating agent, not hazardous heating agent, so always in red. In red pipelines, coolant. Coolant sometimes the better coolant, not better, the common used coolant of at the real plants. It is water, usual recycled water. So green, according to the rules, green color for these pipelines is allowed. Yeah. We see that our coolant loop is opened, but only we have 23% of vapor phase in a product line. We need to see here 0. So we should close a little bit the current value of our feedstock. Click on Z. To understand, we should open temperature device, quantity device, and gradually close our, the best way is use mouse wheel. Yeah, the temperature increased, but when we close our valve, we stopped liquid in this valve, and some vapors due to pressure increase a little bit. And you can see these parameters here, but if you will close it, Yeah, and we aimed our goal here 0. Here the room temperature 25 Celsius degree. And the participants asked, show the shutdown. The shutdowning of our heat exchanger is very simple. To shut down our equipment, first of all, for all heat exchanger system, the main rule, first of all, you should stop the heating engine line and then cooling line. Because if you stop your equipment will melt. So let's finally close supplying. We see that here flow rate is 0. Then we see that the pressure decreasing. Here temperature stable. Then we close this valve. Then we should close shutter valve. Find here mirror window, write 0. Close manual valve. Closing of manual valve valves means that an operator with walkie-talkie directed to this valve and close it manually. Then some liquid in our pipes. So we should open our drainage valves and clean our equipment. Yeah, and in a correct shutdowning, that's very, very important to close all valves to receive the 100 points. So yeah, and we have finished this exercise. So we need to save without saving, because if you save as incomplete, it will be reflected in your statistics, and you can return to this exercise and finish it. Yeah, and the second simulator is Reboiler. Let's turn it in a normal startup. Start calculations, then TF mode. Yeah. Reboilers are using in processes, in rectification columns, in absorption columns, to heat a bottom product. So you see that in this case, bottoms enters to our boiler and goes to heating bottoms. Yeah, let me show the cross section of our boiler. Yeah, here you can see the cross section of our boiler. And let's turn to a boiler. And here you see not only one, two, you can see 3 level devices. In a red color, in a yellow color, and the names are the same. C in this name means control. So this device, level device, alarm type of level device, controls the level and controls the valve. And this device connected with emergency shutdown system will directly stop and shut down all processes if the level in your boiler will be 10% or 40%, less than 15%. So it's very, very important device, and all very, very important devices always duplicated. So you can see here 2 devices, because if one device lying, the second and control device will show correct valves. Yeah. And to understand how to work with your boiler, yeah, and why we need more than 50% of filling. Because here, like in the buffer tank level, such level, and our product, bottom product to heating enters here. And heating device, in this case, in the blue color, and we should support correct level of this device, correct level of this heating agent. Yeah. To start, we should open bottomless product like a feed. And then start filling it by heating agent. And your assignment for next week and championship we will announce tomorrow after guest webinar will be connected with this Reboiler, you should read the reference information about Reboiler. Try manipulate technological management mode in the technological management mode. Then your assignment for today will be it's not official assignment today. You should prepare, and then at this week 24-hour championship, you should done 2 exercises: normal startup, normal shutdown, and don't forget reply and report about your results in WhatsApp chat. Yeah. I will resend this assignment information. Please drop questions to Google Chat. Yeah, thank you for your reaction, and thank you for your attention. So yeah, if there isn't any question, see you tomorrow. Tomorrow we are waiting very, very interesting speaker from Indonesia, and it's a unique opportunity as free